Okay, this is part 2 of a video on transformations. I just wanted to give you an example or two that combined a lot of the different types of transformations together into one question or one example. So here's 2 examples. Okay, the first example asks you to graph this function, and then the second example we're going to look at gives you a graph and asks you to come up with an equation to match. And I think once you get a really good understanding of transformations, you can do both, right? You can have an idea of what the graph's going to look like even before you make the graph and plot the points. And that will give you a way to really get the connection secure between what I see in the equation and what I see in the graph. Okay, let's start with this one. For example, we want to graph this function y equals the absolute value of x plus 3 plus 2. So I have some things, maybe sort of bullet points here at the beginning, because this is what I would recommend you think through before you start to make this graph. Because you know a lot about this equation now that we've talked about the basic graphs and we've talked about the transformations. So what is the basic function that we're working with here? You see the grouping symbol, the absolute value bars? That's the basic function. So that's our starting point, the absolute value of x. What is the shape of that, the graph of the absolute value of x? Do you remember? It's the V shape. Okay, I didn't draw that one very good, but it's a V and it's supposed to be symmetric. Okay. Actually, I should have put that right here, but that's fine. Okay, and then we don't have the basic equation or function here. We have some changes that are made. So what kind of changes are going to be made visually to the graph? So let's start with the plus 2 that I see on the outside. By putting that plus 2 on the outside, what's going to happen to the graph? Anything I do to the outside changes the y values, and it makes a vertical change. So and it's as is. So if I see a plus, it's going to shift it up, just like I would expect. So this is shifted up by 2. Okay, what's the plus 3 that I see inside? What is that going to do to this graph? Anything that's changed on the inside of the function is going to affect the x values. And by affecting the x values, I'm shifting this V shape either left or right. A plus 3 is going to shift it in which direction? Keep in mind that the left and right shift are opposite. So even though I see a plus 3, it's actually going to shift it to the left by 3. Okay, if that's totally bothering you, you can either think about it as being opposite, or you can think of that plus as x minus negative 3. It's always going to be x minus the shift. So the negative 3 in parentheses there would be the shift, and because it's negative, we're shifting it to the left. However you choose to remember that, this one is going to the left. Okay, now we could probably start to put this graph together just by using that information, right? I was at 0, 0 with my basic function, but now I'm left by 3 and up by 2. So that center point, I can kind of use that to keep track of where my V shape is going to be. I could draw my V shape from here. I would like you to have a few more points than just the one. So you could make a T-chart if you like. Think of this almost like this is the center of the V. It's sort of like the vertex of a parabola. All right. And it's happening at negative 3, 2. My V shape is going to happen around that, so I could pick a couple of numbers smaller and a couple of numbers bigger. And I could plug them into my original equation. We probably should do one of those just so that you get a good idea of how that works. Let me put that into the bottom here. I'm going to copy down the function we're working with. Let's say we wanted to plug in -5. And work it out and solve for the y value. -5 plus 3 would be -2. And then I'm going to take the absolute value of that -2. The absolute value is its distance from 0. It's 2 units away from 0. And then 2 plus 2, of course, is 4. So when I plug in -5, I actually get a y value of 4. Okay, and you could do that for all of these numbers that we have here in our t-chart. I'm not going to take the time to write them all out. You could do that on your own. You could pause it right here and try that. Okay, I'm just going to talk you through it. So if I plugged in -4, -4 plus 3 would be -1. Take the absolute value, that's 1 plus 2 is 3. On the other side, I have -2 plus 3 would be +1. Take the absolute value, I have 1 plus 2, also 3. The V shape is symmetric, so when I put in -1 plus 3, I have 2. I'm taking the absolute value, which is still 2, plus 2 would be 4. I can see the symmetry because the y values on equal sides of that middle point are the same. So when I plot these, I have -5, 4, -4, 3, -2, 3, -1, 4. Now this one has not been stretched or compressed. So these lines for the V are very much diagonal lines. Okay, and this would be the graph of that function. It's the absolute value V shape, shifted left by 3 and up by 2. Let's try an example that goes the other way. In this next example, we're given the graph, and we want to come up with an equation that will create that graph. Give the equation for the graph shown below. When we're given a graph, we want to start by looking at the shape. What shape do you see? What is the basic function that we're working with here? This is actually a square root of x graph. The basic graph for the square root of x starts at 0, 0. Looks sort of like a half a parabola on its side like this. Okay, this graph does not look like that. So there have been some changes to it. How can I change the basic graph to look like this graph? Okay, I don't know what order you're going to spot these in, but for one thing, it's reflected, right? If I reflect this shape over the x-axis, I'll have an arc or a curve that looks more in line with what I see up here. So it's reflected over the x-axis. It's flipped over. That would be fine to say too. Okay, and this graph does not start at 0, 0. It starts at -4, 2. So it's been moved left by 4 units, up by 2 units. Now we can take all of those things and incorporate them into an equation. So if my if my graph shape is reflected over the x-axis, this is the one I have to think really hard about. The y values have been changed. And so I must make a change outside of the function. I know a reflection is made by adding a negative, and I want to add a negative outside. Then I can incorporate the shifts. This graph is shifted left by 4, which means on the inside I'm going to have an x plus 4. You could also think of it being a double negative, right? X minus negative 4, which shift it to the left. And then I want to shift it up by 2. That happens on the outside of the basic function. So my square root has ended. Outside of that square root, I'm adding 2, and that's going to shift this whole graph up. You can definitely use your graphing calculator to help you. Try some things out. Plug this into your graphing calculator and see if you get a graph that matches the one that you're given. That's a great way to check yourself on these. I hope this helps. Again, I would recommend lots of practice on these. Try some out, go in the book, look online, see if you can find some examples to test yourself on these ideas. Okay, good luck.